Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review what was covered in week 1. So we started by looking at directed numbers. Now we call them directed numbers based on the sign in front of the number. All these numbers here in blue, they are positive numbers and you're used to working with them. We usually don't write the positive sign, but we can. For example, 4 and plus 4 are the same number. So this plus in front of the 4 is just a direction sign. It indicates that we're talking about 4 above 0. All of these positive numbers are above 0. If we go over here to negative 4, again, the sign, the negative in front of the 4 is just a direction. It tells us this number is 4 less than 0. So all of the positive numbers are to the right of 0, all of the negative numbers are to the left of 0, and 0 is neither positive nor negative. So this is called the number line. The arrows indicate it goes forever in both directions. As we go to the right on the number line, the numbers are getting larger. As we go to the left, the numbers are getting smaller. So we use these two symbols here to compare numbers, to say which number's larger or smaller. So let's have the numbers 4 and 2. You know that 4 is clearly greater than 2. If I give you 4 lollies, you have more than if you have 2 lollies. So which symbol do you use? Well, a crocodile eats the larger number. So think of this as like a crocodile's mouth that wants to eat the 4 because it's larger. So that's obvious. 4 is greater than 2. But if we start looking at negatives, the sign reverses. It turns out negative 4 is actually less than negative 2. So again, crocodile eats the larger number. Here, negative 2 is the larger number. So why is that? Well, numbers to the right are larger. 4 is greater than 2 because 4 sits to the right of 2. Negative 4 is less than negative 2 because it's actually to the left. All right, let's look at some operations with directed numbers now. So when you add a positive number, it makes it larger. When you subtract a positive number, it makes the number smaller. Now that probably seems like common sense. Why would I even point it out? Well, we need to be able to do calculations like this with negative numbers. Negative 7 minus 4. See, so many people tell me the answer to this would be negative 3. But negative 3 is actually larger than what I started with. My answer needs to be smaller than what I started with because I'm subtracting 4. So what do I mean by moves right or moves left? Well, if you're stuck, you can draw up a number line. So if we have negative 7 here, that's where we start. If we want to subtract 4, we actually go to the left. So we start here at negative 7. The next number to the left will be negative 8, negative 9, negative 10, and then negative 11. So negative 7 minus 4 equals negative 11. Now, sometimes you'll have to do calculations where you have two signs next to each other. So if those two signs next to each other are the same, both negatives or both positives, you change it to a positive. If they are different, you change it to a negative. Probably doesn't make sense. Let's look at some examples. So let's say I have negative 15 subtract negative 8. Well, what I have here are two minuses next to each other. Two minus signs next to each other make a plus. So this is actually negative 15 plus 8, which is negative 7. So we've turned this into adding a positive number, so my answer should be larger than what I started with. So if I have 20 plus negative 32, I have a plus and a minus next to each other. They just turn into one big minus. So this is 20 minus 32. And again, if I'm subtracting a positive number, I move to the left, I make it smaller. So 20 minus 32 will, of course, give me negative 12. All right, let's look at some multiplication and division. So when multiplying or dividing directed numbers, it's not about the signs being next to each other anymore. It's about whether the numbers are positive or negative. So when you're multiplying or dividing, if both numbers have the same sign, if they're both negative or both positive, your answer is a positive number. And if the two numbers have a different sign, one's positive, one's negative, you get a negative answer. Let's look at some examples. So negative 7 times 8. Well, let's just do 7 times 8 we know is 56. But because this was a negative times a positive, negative times positive, the answer is negative. So negative 7 times 8 is negative 56. So in this one, we're dividing a negative by a negative. So if you multiply or divide two negatives, the answer is positive. So this will just be 4 because 32 divided by 8 is 4. So what about negative 5 squared? This is a tricky one. Remember, squaring means to times something by itself. So this is actually a negative times a negative and will give us a positive answer. What about negative 3 to the power of 3? Well, raising something to the power of 3 doesn't mean times 3 by 3. It means times the number by itself 3 times. So what we do is we do the first two numbers first. So a negative times a negative is a positive. So negative 3 times negative 3, just this part in red, gives me an answer of positive 9. So then I times that answer by negative 3, positive times a negative, and my answer is, of course, negative. So sometimes you'll get a question like this where you have to find the number that goes in the box. So what do I times by 5 to get 45? Well, I'm sure you all know the answer to that is 9. 45 divided by 5 is 9. So if I want to go from a negative number to a positive answer, the 9, however, has to be negative. And that's all there is to operations with directed numbers. Let's now take a look at fractions. So here I've got two pizzas. First one I divided into 8 slices. The second I divided into 4. So if I've shaded in the amount of pizza you get, for the first pizza, you receive 2/8 of the pizza. So this is a fraction. A fraction is just a number divided by another number. So the top number is called the numerator. That's how many pieces you get. So here I've got 2 pieces. The bottom number, the denominator, tells you how many pieces you have in total. So this is basically saying that I've shaded in 2 out of 8 pieces. Whereas over here, I've shaded in 1 and there are 4 pieces in total. So we can see from this, if you get 2/8 of the pizza, you get exactly the same amount as if you get 1/4 of the pizza. 2/8 and 1/4 are equivalent fractions. Equivalent fractions means they have the same value. So 2/8 and 1/4 both equal 0.25. It's the same amount. It also means they occupy the same position on the number line. So here I've drawn a number line that just goes from 0 to 1. See, all of these fractions, they are parts of a whole. 1/8 is more than 0, but it's not quite a whole. 6/8 is more than 0, but not quite a whole. So in blue, I've divided the number line into quarters. 1/4, 2/4, which is the same as a half, 3/4, and 1, which is the same as 4/4. But you can see that here at the top, in green, I've divided the number line into 8s. 2/8 and 1/4 occupy the same position on the number line because they are equal. Similarly, 4/8, 2/4, and a half are the same number. They all equal 0.5. 6/8 and 3/4 are the same number. They both equal 0.75. So that's what it means for fractions to be equivalent. They're basically the same thing, just written a different way. So we can use equivalent fractions to find unknown amounts. The golden rule for fractions, what you do to the top, you must do to the bottom. On the other hand, what you do to the bottom, you must do to the top. So let's look at a question like this. We want to find what number goes in the top. So what have we done to the bottom? Well, we've actually multiplied the bottom by 6. What you do to the bottom, you must do to the top. So if I also times this top number by 6, 3 times 6 is 18, I will have an equivalent fraction. 3/5 and 18 over 30 are both the same number. Both equal 0.6. And the same is true for division. So if I look at these two fractions, to go from 24 to 3, I have to divide by 8. So what I do to the top, I have to do to the bottom. So 80 divided by 8 is 10. 24 over 80 and 3 over 10 are the same number. They're equivalent fractions, both equal 0.3. If I give you 24/80ths of a pizza, you get exactly the same amount as if I give you 3/10ths of a pizza. So hopefully you've realized there are heaps of different ways to write the same fraction. Turns out all of these fractions here are equal. 3/9 is the same as 8/24, same as a third, 10/30, 15/45. All of these are equivalent fractions. But of these 5 fractions, we say 1/3 is in simplest form. It's the same as all the other fractions, but notice that it has a lower numerator and a lower denominator. So we need to be able to simplify fractions. We need to be able to take fractions like these and write them in their simplest form, because simplest form means the fraction's so much easier to work with. So if I simplify 10/30, I get a third. If I simplify 3/9, I get a third. So simplifying a fraction, all it means is we find another fraction that's equal but that has lower numerator and denominator. So the way you do this is by dividing both numbers, the numerator and denominator, by their highest common factor. So for example, let's say I want to simplify 12/18. So the highest number that goes into 12 and also goes into 18 is 6. So I can divide the top number by 6, the numerator by 6, as long as I divide the denominator by 6. So 12 divides 6 is 2 and 18 divides 6 is 3. 12/18 and 2/3 are equivalent fractions, but this one is much simpler. Now, not every fraction can be simplified. I can't simplify 5/12 because their highest common factor is 1. They don't have any other common factors. There's nothing I can divide top and bottom by to reduce these numbers. So not every fraction can be simplified. Now, this is a special type of fraction called an improper fraction, where the numerator, top number, is greater than the bottom number, the denominator. We can simplify this in the same way. What we have to do is find the highest number that goes into 72 that also goes into 27. So the factors of 27 are 1, 3, 9, and 27. 9 is the highest number that also goes into 72. 9 is the highest common factor of both. So I divide 72 by 9, I divide 27 by 9. I can do whatever I want to the top number as long as I do it to the bottom. So 72/27 is the same as 8/3. Once again, this is an improper fraction. So one more thing to look at, let's look at comparing fractions. So we can use equivalent fractions to compare them. When I say compare fractions, I mean see which is larger. Now, sometimes we might need the lowest common multiple. So let's look at these two fractions here, 3/5 and 2/5. Well, you know clearly 3/5 is larger than 2/5. So crocodile eats the larger number. Greater than symbol points to the right. That's easy. These two are easy to compare because they had the same denominator. But what about these two fractions? It's not immediately obvious which of these fractions is larger because they have a different denominator. But what we can do is use equivalent fractions. We can find an equivalent fraction for this and an equivalent fraction for this that have the same denominator. Here we need to use the lowest common multiple. So the lowest number divisible by 8 that's also divisible by 5 is 40. 40 is the lowest multiple of 5 that's also a multiple of 8. So how does that help? Well, what I can do is I can times this bottom number by 8 and I will make this denominator 40. I can times the bottom by 8 as long as I times the top by 8. Similarly, over here, if I want this denominator to turn into 40, I can times it by 5. I can times the bottom by 5 as long as I times the top by 5. So it turns out 3/5, so 3 times 8 is 24, 5 times 8 is 40. 3/5 is the same, it's equivalent to 24/40. Similarly, 5 times 5 is 25. 5/8 is 25/40. Now that these two fractions have the same denominator, it's easy to compare them. It's easy to see this one is larger. So 24/40 is less than 25/40. So I want the crocodile to eat the larger number. I write it like that. 3/5 is actually less than 5/8. So let's look at this question, which is a bit harder. Which fraction is halfway between a third and a fifth? So you're probably looking at it and you think, oh, cool, it's just a quarter. No, that's not the answer. A quarter is actually closer to a fifth than to a third. Okay, so if it's not a quarter, how do I do it? Well, I can use equivalent fractions. Once again, I'm going to use the trick I used here. I'm going to make these two fractions have the same denominator. So I need the lowest common multiple. The lowest common multiple of 3 and 5 is 15. So if I times this bottom by 5 and the top by 5, I will turn 1/3 into 5 over 15. So over here, I want this fraction to also have denominator 15. So I need to times the bottom by 3. I can times the bottom by 3 as long as I times the top by 3. So clearly 1 over 5 is 3 over 15. 1 over 5, 3 over 15 are equivalent fractions. So I want to find the number halfway between these two. Well, now it's actually really easy. Halfway between 5 of something and 3 of something is 4 of something. Halfway between 5 over 15 and 3 over 15 is 4 over 15. That number wasn't immediately obvious. We needed to use equivalent fractions. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.